Hi students, welcome to Max Point of View. Today we are going to learn how to identify whether the given resistance are in series or they are in parallel. So first we'll learn about series. After this one we'll go for parallel. Okay, listen. Whenever we need to identify whether they are in series or parallel, we need to identify how many wires are connected between them. What do you mean by that? Listen, whenever there is a resistors, okay, how we can connect them? Using a wire, correct? One wire will be coming from this resistor and one wire will coming from this resistors. Okay, so whenever these two are joined, how many wires are connected? Totally two. Okay, now one wire will be coming from this resistor and one wire will be coming from this resistor. How many wires are joined? Two. If the number of wires joined are 2, then it is in series. More than 2, it is always parallel. More than 2 means anything. It may be 3, 4, 5, anything. Okay. If the number of wires joined by 2 resistors are only 2, then they are in series. Okay. Less than 2, it is not possible. Less than 2 means they are not even connected only. This example is same as this one. See, from this resistor one wire is coming and this resistor one wire is coming, correct? These two are connected somewhere here, so how many wires are there? 2 wires, so they are in series. Now we'll talk about this one. See where these two are connected, somewhere here. For this point, how many wires are coming? One wire from this resistor and one wire from this resistor. So totally how many wires? 2 wires. This is in series. Next we'll talk about these two. These two are connected here. One wire is coming from this resistor, one wire is coming from this resistor, so this is in series. We'll talk about these two. From one wire, from this resistance one wire is coming, from this resistor one wire is coming, so totally 2. Again here also 2, here also 2. So all of them are in series. All of them are in series. Say in exam definitely you'll get both series and parallel. Don't worry about it. First we'll identify whether they are in series or parallel. I will help you to solve all those combinations. Now listen. Now see this diagram and this diagram. This is a square and this is a rhombus. See, if you tilt it like this, the same diagram it is here. See, at this point these two resistors are connected. One wire is coming from this resistor and one wire is coming from this resistor. So only two wires. At this point same two wires and two wires. Once we identify whether these are in series, then it is easy to solve. See, solving series connection, it is very easy. Just adding the values. I'll give you some examples. Listen, assume this is 2 ohm and this is 3 ohm. This is the formula for resistance in series. S represents series. Listen, and we need to understand why we need to do all these things. Okay, why we need to do all these things? Whether why do you need to identify whether they are in series or parallel? Listen, assume these kind of resistors are in a circuit. Instead of using so many resistors, we will use only one resistance, that is the final value. Okay, after solving all these things we will get one value, correct? One resistance value. That resistance we are going to use it in circuit instead of using so many resistance. Okay, while solving the question you will understand. Okay, listen, these two are in series, correct? Series formula is adding all the resistance. How many resistance we have in this case? 2 resistance. Just add them. So 2 plus 3, that is 5 ohm. See, once we add it, you know what happens? Once we add it, these two resistance will become one resistance. Okay, once we add it, okay, these two resistance will become one resistance. Next, see, this connection is exactly like this one only. If I extend like this, see, if I move this resistance like this connection is same as this one only. So assume this is 4 ohm and this is 3 ohm. So total RS will be 7 ohm. Okay, so using these two, after solving these two, we'll get only one resistance. Okay, next, assume this is 1, 2, 3, 4. We know all of them are in series. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. Okay, so after solving all these things, how many resistance we got? We get only one resistance. See, After solving all these things, I'll get one resistance. That value will be 10 ohm. How to use this resistance while solving the problems you will understand. Okay, first we are identifying whether they are in series. Once we identify, how to solve these kind of things. Again, 2, 2, 2, 2. Assume all the values of resistance is 2. Then answer will be 8 ohm. Okay, and 8 ohm will be the value of only one resistance after solving all these things. So this is how you identify series connection and solve them. Now we learn how to identify whether the resistance are in parallel or not. Okay, so when it comes to, if you have understood series connection, then the parallel connection is also easy. Only the formula is different. Listen, first we'll identify, then we'll go for the formula. Listen, these two resistors are connected here and here, correct? Here and here. But in series connection we learned, whenever they have connected somewhere, we have to see how many number of wires are connected. See, what at this point these two are connected, correct? One wire is coming from this resistor, one wire is coming from this resistor. See, there is one more extended line, right? This one more extended line is coming. See, this is also you have to include as a wire only. One wire is coming here, one wire is coming from this resistor, one wire is coming from this resistor. So totally how many resistors are connected? How many wires are there? 3 wires. Then definitely this is in parallel. So at the junction point, at the connected point, you have to see how many wires are there. See, at this point also, at this point, one wire is coming from this resistor, one wire is coming from, will identify as R1, R2. One wire is coming from R1, one wire is coming from R2, and one more wire is coming extended wire, right? So totally there are 3 wires. So this is in parallel. Now at this point, assume this is R1, R2 and R3. See, at this point see, if the diagram is like this or like this, both are same. Both are same. Listen. Now at this point, how many wires are connected? One wire is from R1, one wire is from R2, one wire is from R3. So there are 3 wires and one more extended wire, correct? One more extended wire. So totally 4 wires are there at this junction point. Definitely this is in parallel. More than 2, it is always parallel. Equal to 2, it is series. Less than 2, it is not possible. Okay, next, at this point, see, these two resistors R2 and R3 are connected here, correct? R2 and R3 are connected here. How many wires are there? One wire is coming from R2, one wire is coming from R3, and one more wire is coming from, see, at this point, okay, this wire is also coming here only, and one more extended wire, this is also coming here only. So totally 4 wires are there. Definitely this is in parallel. Now we'll talk about this one. Next, listen, these two, we'll see about these two. How many wires are there? One wire is coming from R1, R2, R3, R4, R5. Okay, one wire is coming from R1 and one more wire is coming from R2. So how many wires are there? Only 2. This is definitely in series. This is definitely in series. Now we'll see here at this point. Okay, one wire is coming from R1, one wire is coming from R4, one wire is coming from R3. So totally 3. These 3 are connected in parallel. At this point, these 2 are connected in series. At this point, 3 wires are coming. 1, 2, 3. So this is in parallel. Okay, first we are just identifying it. I'll teach you how to solve them. Listen. Now we'll talk about this point. Okay. How many wires are connected at this point? One wire is coming from this resistor R1, R2, R3, R4, R5, R6. Just naming instead of giving values. R1, from R1 one wire, from R2 one wire, from R3 this wire is also connected here only. I know this wire is connected here, but these two are joined and coming here, correct? These two are joined and coming here. So totally how many wires? 1, 2, 3. So totally 3 wires are connected. Definitely they are in parallel. Listen, you will be thinking we are talking about only R1 and R2. Why we have to include this one? See, if you think like that, in the world there will be no parallel connection only. Okay, see, whenever we are talking about R1 and R2, we know we are talking about only R1 and R2, but how many wires are connected between them? One wire from this one wire from this one, and one more wire from this one. And see, at this point, one wire from R1, one wire from R6, one wire from R5. So totally three wires parallel. At this point also, one wire from R6, R5 and R4. So parallel. At this point also, one wire from R4, one wire from R2, and R2 and R3 are connected and coming together. So totally 3 wires. So they are in parallel connection. So if you identify which is series and which is parallel, then aramsa we can go for the formula. See, in series connection, you know, okay, just applying the formula, adding them, that's it. But when it comes to parallel, RP is equal to 1 by R1 plus 1 by R2, 1 by R3, it keeps on going. Okay, whenever, listen, whatever the values, I'll give you one example, I'll show one example. Listen, assume we'll talk about this question. Okay, 2 3 4 2 3 4 1 by RP is equal to 1 by 2. See, we have to take the reciprocal of these values. 1 by 3 plus 1 by 4. What is the LCM? That is 12. So this will be 6, this will be 4, and this will be 3. Answer will be 13 by 12. Correct? This is the final answer. Correct? No, completely wrong. Why? Because we are not finding RP, resistance in parallel. We are finding 1 by RP. So to find RP, we have to take the value of this final reciprocal. We have to take at this final step. That will be 12 by 13. 12 by 13. See, to find the resistance in parallel, few students will forget to take reciprocal at the end. So for them, we have one more formula. Listen, but this formula, you know, there is a problem. This formula is limited to two different, okay, if they are connected only two resistance in parallel, when they are going to use this formula, listen, RP is equal to R1 R2 by R1 plus R2. Here, if these two, only two resistors are there, we are going to use this formula. If three resistors are there, we are going to use this formula. R1 R2 R2 R3 plus R1 R3. This one. See, you can go for the textbook formula. This is the textbook formula, okay, but you should not forget to take reciprocal. Sometimes these formulas will be easy, but sometimes the textbook formula will be easy. So whichever is easy for you, you can go for it. This formula is only applicable when only there are two resistors are in parallel. This formula is only applicable only when three resistors are in parallel. More than three, we have to definitely go for the textbook formula only. So it keeps on going. Okay, we have to take the LCM, and normally we have to calculate, but at the end we have to take the reciprocal. Till now we have understood how to identify whether they are in series or parallel. Now we have to learn how to solve them. Then only we will understand completely. That we have solved from ICSE grade 10 physics textbook. Correct? That is from electricity part B, from the question number 6 to question number 19. That video poster will be coming at the end of this video, and it is also available in the description box. Question number 6C, we have solved so many questions in that video. From question number 6 to question number 19, you are going to learn how to solve resistance in series and resistance in parallel. Thank you.